Welcome to Landis Performance Channel. This is part 2 of our 68 Camaro HP Terminator installation. Now we're going to go ahead and tune the vehicle. Okay, so now that the system is installed and we turn the key on, we're going to go into tuning. We're going to go to Wizard. We're going to start a file. We have a Holley TBI. It's a Terminator. No automatic transmission. Smaller than 409 cubic inch. We're going to put factory stock. No for ECU control timing. CD box tack out is correct. And now it has created a calibration. I'm going to upload it. Now we have to turn the key off for 4 seconds to make it take effect. Okay, so on this screen, we can see our IAC is at 5%. So what we want to do is let the engine get to temperature. It's at 99 currently. We want to let it get up to about 125. And then we want to adjust the throttle blade to where that is near 0 at the target idle speed. We can find target idle speed by going back, go home, in the tuning, basic idle, and our target is 750 RPM. So that's where our target's going to be. So we want the engine warm and idle around 725 to 775 with 1 or 0 IAC. That way the IAC has full control of the vehicle. So we go back home, go to monitor, multi-port gauges and outputs, and we can see where our IAC is at. And we can see that the engine is slowly warming up. We can also see the air-fuel ratio, battery voltage. Now we can go back here, go back 1, go to air-fuel ratio. Now we can see our actual AFR and our target AFR, our closed loop correction, and our fuel learn. So right now we're running with almost 0 correction. So the tune is pretty close. So we'll just wait for the engine to warm up a second. Okay, so our engine's warmed up. We're at 160 degrees and our IAC position is at 2, and we're idling right around the 750 target point. So we're good. If the idle speed was correct but the IAC was at 15 or 17%, we would have to open the throttle blade so that the IAC would not have to bypass as much air. So that's how you adjust that. So now we can go back to our air-fuel ratio, and now we can see that closed loop compensation is at 1 or 2%, and our fuel learn is at 6%. So it's doing a little bit of fuel add right now, which it's doing during its learning. And you can go in, go back to home, tuning. You can do basic fuel, target AFR. So we want to target a leaner idle AFR. So we're going to go to, because this motor is pretty stock, we're going to go to 14.5. All right, I can cruise is okay. We should probably lean that out some more too. And our watt, we'll make that 12.8. Okay, so now we go back to our monitor. Now you can see it's changing the corrections because it's trying to match. Here's our target, here's our actual, and it's trying to adjust it to make it work. Here's your outputs for fan on, fan off, AC shut off at 90%. Those are all good. We're running a mechanical fan, so we really don't care about those. We can go into advanced. You can do advanced cold start, enrichment, and all that. That's basically it. So now what we'll do is we'll hook up a laptop and show the differences of what the laptop can do. Okay, so this system is on a Holley 4 build 110, so we'll open the software. Now at this point we are going to download from ECU. Now we're going to acknowledge it has a HP EFI system, and synchronizing with the computer. We want to calibrate sync time. We had the tune that was in the ECU that we generated from the handheld. So we go to tuning, to fuel, and there's our basic fuel map. Now we'll go here. I didn't stay connected. Okay, so now we have the actual software that was written by the handheld in our laptop, and we can now see what it's doing. There's the cursor where it's idling at, which we can watch live. We can go to our learn table, and that's where it's been adjusting the learn. Go to target AFR. Okay, so this is our target AFR table, and you can see that the computer did generate a AFR table, but it's really not that good. Go ahead and make some corrections here. They got DXL at 13.5. That's going to be awful rich on DXL and burns a bunch of extra fuel that we don't need to. And at watt, at 91%, it's still at 12.9. That's probably not where we really want to be. So we're going to go ahead and highlight these. Go across here, right click, and we want to fill columns. So what that's going to do is interpolate those numbers for us. And we'll move the cursor. And now you can see that we're 14.5, 14.1, and it slowly goes to richer as you go to wide open throttle. We don't need to go and just pig fat. We want to make the car run clean. Now, one thing you can't do with the handheld easily that you can do with your laptop is your acceleration enrichment. Now, this is a very rich acceleration enrichment. We don't need that much fuel going into the engine. So we'll go make that a 40, and then we'll interpolate across. Right click on the mouse and fill row values. See, it still accelerates just as good, but it's got way less fuel in it now. So now, we usually like to have a little bit of a turn here. So what we're going to do is we're going to raise this first one up to like there, and then we'll interpolate again. Right click again and fill rows. And what that does is when you come off of cracked idle and it needs acceleration fuel, as if it was a carburetor with this accelerator pump, you got a little tip in there. We'll do the same thing with map rate of change. These numbers are a lot better, but we can make them even better. And right click, fill rows. Those are a little bit closer to where we like to see them at. We'll go to our gauges. And here's our gauges showing us what's going on. So we got engine RPM, we got IAC position, coolant temp, AFR actual. They've had flex fuel, we're not using that. Air temp, map, which is your engine vacuum. And you can see here we're learning and we're in closed loop and we're running around 1% and 7%. So idling wise, this thing is basically tuned. Now what we'll want to do is take it out and drive it. Let's go to the learn table. What we want to do is go out and drive it and populate as much of this screen as we can. Then we would click transfer to base, and that would adjust the base fuel table, and then you drive it again. Once you do that and this table is less than 10% correction, then you're 90% done. So what we would do then is click on the ECU icon, go to closed loop, learn, and we're gonna go ahead and do that now. But we could take all these numbers and make these 50%. And then we go to learn parameters, which are currently at 150%. They do that because they're not sure where the motor is going to want to go. We'll leave that for now, but what we'll do is once we get the car driving and all of our whole table is less than 10%, we'll lower that down to 20. And that way it will still control what's going on, but if the O2 sensor went bad, it can't add a ton of fuel. If it had 150% in the screen, the O2 sensor goes bad and shows lean, the computer would then add up to 150% trying to correct it. That would foul the plugs and probably leave you stranded, so you don't want to do that. Anyway, let's go out and do a road test, and then we will see where we're at when we get back. Okay, so now with this help of an assistant, we're gonna go drive this car around and try to get this tune working. So my buddy Chuck is driving, and we're gonna try to drive this thing around. So I like to keep the gauges up and the AFR table up at the same time so I can monitor both. And we'll switch this around. Fuel tuning, learning mode, there we go. Okay, go ahead. All right, well, sorry we couldn't do the tuning on the road test. There's just way too much glare on the screen, so I'm sure you couldn't see anything. So we're back at the shop and we're gonna do it show on a desktop. Unfortunately, it won't be live tuning, but we can show you what we're doing. So what I like to do is, as you saw in the video, I like to get the base fuel table up. I'll get our gauges up, which of course our gauges don't show anything because they're not connected to a vehicle. And then I go down here and I'll switch this around to learn tuning, and that'll show below RPM. You'll have LED simulation on learn and on closed loop, or blue and green. Green meaning they're active or live. And then here they'll show you the percentages. So as you're driving the car around, you'll see the cursor rolling through the screen here. And what I'll do is I'll circumnavigate the live tuning, and I will highlight a section and then right click and make an adjustment when I see the closed loop trending a certain way. So say the closed loop is trending in a negative way, then I'll come down to offset and I will do a negative, like depending on how much numbers there are, but you know, I'll do a -2 or something, -1, and then that'll adjust that area, and then we can continue watching. And as we get the closed loop and the learn to a very small number, then we're good. Then what we do is go back, and then we would highlight around it in that direction, and so forth, and interpolate the rest of the numbers so that the fuel map is smooth. So driving around doing that, we can go back to the learn table, and there's the cells that the map sensor saw during our drive. And if you can see, we can zoom in here, the numbers are fairly small. I think our biggest number on there is a -4, so it's pulling out -4 in fuel. So that's what we would do. And then after you've done that, you want to go back to your fuel graph and take a look at where you're at. Like right here, we can see there's a small dip in there, so we know that there's a hole in the cell in the map that we need to correct. So we'll just do this for a couple different times, and then we'll end up with a base fuel table like that. This will be our final, and if you go back to your fuel graph, you'll see it's fairly smooth, no real dips or craters in it, and it's in pretty good shape. Now you can just drive it with the learn and just let it do itself until until you feel it drives really well. And then once you get to that point, if this cell is completely full, then you can go ahead and transfer to base, and it will make the adjustments for you. I've always tuned EFI, so I like to tune it myself and just kind of use the learning as a backup. And when we're all done, and we feel the car is ready to go, we go back to our closed loop parameters. We change the whole table to 20, and on our learn, we change the whole table to 20 also. And you see in the idling area, I changed it to 15. So what that'll do is, if your O2 sensor goes bad, or you have a sensor that is wonky, it'll keep it from over fueling the engine until you can get it straightened out. We've had conditions where an O2 sensor goes bad. These tables were not adjusted, they were at 100%. So with closed loop at 100 and learn at 100, it actually tried to double the fuel that was going into the engine, and it wouldn't even run to get it off the road. So it's something you want to do, is lower these numbers. You want to start out with the numbers where they are in the 100 area, and once you make your first drive and go to your learn table and see that the biggest learn number was, say, 20, well, then bring that table down to 30, and then continue tuning it. And as you tune it, you can keep bringing these numbers down to where it's a small amount of adjustment in case something went bad. But it's good to have some numbers in there. You don't want to turn them off, because barometric conditions and engine wear and stuff like that, you want it to still be able to adjust some. So just something you have to kind of play with. And that's pretty much what we did on this. This car didn't have timing, so we have no timing to control. We have the idle adjustment you saw earlier in the video. We can go to there. One of the things that we usually do is IAC. We usually put in the slow mode. There's a couple different ones. Idle spark we didn't turn on this car because it doesn't have idle control. What idle spark does is, as the engine errors off of the target idle, it'll adjust timing to try to smooth the engine out. And that's about it for this one. If you have a car that the IAC isn't operating properly on, go back and look at our other videos. We have a video on that, a case study where the IAC wasn't wired properly. There's a couple different IAC motors and they have different pinouts, so your harness may not be pinned out for the IAC that you have. That can cause a lot of idling issues. So go back and check that video out. Hope this was helpful. I think in the future we're going to do a complete series of Holley tuning where we start from opening the file to go ahead and tuning a car. We'll try to do that on a dyno where we won't have the glare and we can actually do it live tuning, and you can see how we approach that. So always save your files. You look on this vehicle. You can see that always save your files, and as you can see, we had our initial leaving the shop, and then as we were making the adjustments, we have adjustment 1, adjustment 2, 3, 4, 5, 6, and once we were back to the shop and we were happy with what we had final, and then we had a date that it was done. So always save your files, and that way if you make an adjustment you don't like the way the car runs, you can go back to the previous file and correct that problem. You don't have to remember where you were or what changes you made. Always try to make 1 or 2 changes at a time. I prefer 1 change at a time. Save the file, make another adjustment, save the file to a new name, and just keep stacking your files until you have them all done. Then what I do is I put them in a folder and then only have the finished product on the top page. That way you can have it how you want it. As you can see, if we go back, you can see we have, this is just a one version of software, and we have quite a few different files of different cars we've tuned, and we just keep creating a library for all that. Anyway, I hope this was helpful. Subscribe to the channel, it's free. Give us a like if you like it, leave comments, click the bell if you want to get instant notification when we put more tuning and other things out. Thanks for watching.